think we're going to pass it to Yeongseo now. Is this
Hello, my name is Yeongseo Yu. Thanks for the presentation, Keith. I'm going to give you a brief introduction how we evaluated our design performance on the stormwater runoff decrease. So first of all, we were curious where the stormwater would flow and got accumulated according to the site topography. So we try to visualize water, the water flow accumulation with the contour data, through 3D Rhino grasshopper software. And for the result, as you can see the graphic, the darker blue colored area means the more probability of the rainwater flow accumulation. And also, what interesting thing is these potentially accumulative areas were very closely located to the existing sewers. So when we check it on the ArcGIS. Next slide, please. So based on this result, we divided our entire site into 4 subcatchments, and we varied and adjust the level of infiltration pavement or soil conditions by integrating different green infrastructure solutions such as rain garden, bioswale, and filtration trench in previous pavement based on our design proposal for each subcatchment. Next slide, please. And this is the swim analysis result. The left one represents the rainwater runoff comparison of the sum of the 4 catchment entire site. And the right 4 graphs respectively represent each subcatchments. So in each graph, the purple color represents the precipitation, the gray means the runoff under the existing condition, and the green color represents the runoff of our design proposal. So basically please go back to the previous slide. Yeah, so we used 15 minutes precipitation real data of January 18, 2012, and which was the most heavily rainy day of the year. And the reason why we use a bit old data is to ensure a more detailed and elaborated rain event simulation than the 1-hour precipitation data. So next slide, please. And this is a more reasonable and translated graph based on the previous results. Our design for the entire site shows a significant improvement. So for example, our design reduced rainwater peak runoff by up to 0.64 cubic feet per second, and also delayed the peak flow rates by approximately 20 minutes. And our design also shows a meaningful enhancement in infiltration rate. There is an increase to 6.14 inch per hour compared to the existing site that is 3.52 inch per hour, which can be translated to a potential reduction of up to 75% in peak runoff during the intense rainfall events. And one final important note is that our swim analysis are based on a very kind of simplified assumptions. So just considering a few parameters such as the pavement coverage, soil depth, soil characteristic, moisture, not stick to a very accurate and detailed information on the surface geometry and soil profile. So there might be a potential variation existing in the research. So yeah.